Hello there. Welcome to section 4 of Unit 3. And in this section, we'll be talking about the atoms and the periodic table. Let's look at the objective of this section. We have 4 objectives here, and the first objective is to be able to describe the behavior of subatomic particles in electric fields. Secondly, we should be able to identify and define isotopes. Thirdly, describe the arrangement of elements in a periodic table. And lastly, we should be able to calculate the average atomic mass of all isotopes of an element. Let's look at the overview of the structure of the atom. I hope you do remember from our previous sections and units where we talk about the properties of the subatomic particles. That is the proton, neutron, and the electron. Where we got to know that the symbol of proton, neutron, and electron is P, N, and E respectively. And also the masses is 1 n 1 over 2000, which is negligible to proton, neutron, and electron respectively, with the charges to be positive 1, no charge, and negative 1, with proton, neutron, and electron respectively. There are some factors that you have to consider in these physical properties. And one is the mass of the atom is concentrated in the nucleus of an atom. This is because the mass of the electron is what? Is negligible. And the neutron has no charge. It is neutral. An atom is also neutral because it always contains as many positive protons as negative electrons. Meaning because we have most of the mass of an atom embedded in the nucleus, the charge tends to be neutral, which is being considered by the nucleus than the electron. Now, let's look at the behavior of protons, neutrons, and electrons in electric field. What actually happens in a beam of each of these particles if it's passed through between two electrically charged plates, say one positive and one negative? Opposite charges will attract, right? Protons are positively charged and so would be deflected on a curved path towards the negative plate. Likewise, the electrons are negatively charged and so would be deflected on a curved path towards the what? The positive plate. For the neutrons, has no charge, right? And so will continue to be on a straight line. So let's ask this question. What exactly happens depends on whether the beam of the particles enter the electric field with various particles having the same speed or same energies. If the beam of these sorts of particles, all with the same energy, are passed between two electrical charge plates, protons will deflect on a curved path towards the negative plate. Electrons will deflect on a curved path towards the what? Positive plate. And the amount of deflection is exactly the same in the electron beam as in the proton beam, if the energies are what? The same. But of course, it is of opposite what? Direction. And the neutrons continue to be what? In a straight line. So for every element that we know, it has a particular atomic number and a mass number. Let's look at the definitions of this atomic number and a mass number. Atomic number here is the number of protons in the nucleus of an atom equals the number of electrons in a neutral atom. While the mass number is the number of protons plus the number of electrons. And anytime there's a graphical representation of an element having an alphabet written at the top here and one at the down here, the down here always represents the atomic number, and the one at the top here always represents the mass number, which we know to be the protons plus the neutrons. Let's talk about isobars and isotopes here. What's an isobar? Isobars are atoms with the same number of mass number, but different atomic numbers. So we have some atoms, some elements that may exhibit the same mass number, but may have a different atomic number. And we do remember from our previous slides that always we write the atomic number beneath here and the mass number at the top here. So considering an element like argon, potassium, and calcium, they tend to have the same mass number of 40, 40, and 40, but different atomic numbers. That is 18 for argon, 19 for potassium, and 20 for calcium. Let's look at another property we call isotopes. And I hope you've all heard of isotopes before. Isotopes are atoms with identical atomic number but different mass number. So it's like the opposite of the isobars. So this time around, what we have here is our atomic number. But atomic number here is going to be the same, right? But the mass number is going to be what? Is going to be different. So don't confuse yourself of isobars and isotopes. So from here, I hope you will be able to identify some elements in the periodic table that may be considered as isobars, and also identify some elements in the periodic table that can also be considered as what? Isotopes. Talking about chlorine and others. Let's talk about the atomic weight. The atomic weight values represent the weighted average of masses of all natural occurring isotopes in an element. And anytime you are calculating the atomic weight, it's always equal to the weighted average of an element natural occurring isotopes, right? So you always have the percentage of the abundance of the isotope in a decimal form times the mass of the isotope 1, followed by the second one times its mass, that's the isotope 2, followed to the isotope 3. So should in case you have the number of elements to be 4, meaning there will be a second one, a last one here, multiplying with the mass of isotope 4. And should in case it's only 2, you just take only these 2. I hope you do understand. Let's look at the periodic table. The periodic table is a table containing all elements arranged in ascending order form from the one with the lowest atomic number to the one with the highest atomic number. There are 8 vertical groups, that's in columns, in the periodic table. The group number is equal to the number of electrons at the outermost energy shell of the atom, that's the valence shell. This is why elements of the same group share the same chemical properties. There are 7 horizontal periods in the periodic table. The periodic number is the number of occupied energy shells in the atom of the element in the periodic table. So if an element has 3 valence electrons, it will be placed in group 3, right? And if it has 4 occupied energy shells, it will be in period 4. Let's look at the elements in the periodic table. We can find the physical properties of the elements in the periodic table, and we can also find the chemical properties of elements in the periodic table. Depending on where we find the elements in the periodic table, it can be a metal, an alkaline, a non-metal, and others. Some of the physical properties that we can consider with the elements in the periodic table is the state in room temperature, their density, appearance, melting point, boiling point, their malleability, ductility, electrical conductivity, heat conductivity, and sonority. Talking about their chemical properties, say for metals and non-metals, these are some of the properties that we can define. So for the metals, they have either 1, 2, 3 valence electron. Likewise, the non-metals, they can either have 4, 5, 6, 7, 8 valence electron, except for what? Helium, which has 2. So anytime you find an element and you know the number of electrons or you know the atomic number, you could be able to define or find out whether the element is a metal or a non-metal by just drawing and finding out their valence electrons. Secondly, they lose electrons forming positive ions. And for the nonmetals, they gain an electrons forming positive ions. For the metals, they are reducing agents, and for the nonmetals, they are oxidizing agents. For the metals, they form basic or amphoteric compounds, and for the nonmetals, they form acidic or natural compounds. And lastly, metals forms ionic compounds with nonmetals, whilst nonmetals form either ionic compounds with metals or covalent compounds with nonmetals.